I'm Hisham from the Viral Communications Group. You can't buy imagination, but you can become a member of the Media Lab, and that's as close as it gets to it. So if you're a corporate company, know that you can get an insurance policy for the future by joining the MIT Media Lab and becoming a member company. All right, that's my plug.
He doesn't get a commission if you join.
Exactly.
But he loves working with companies.
So check it out real quick. We're just going to go down the line. If you guys could introduce yourself and what research you're doing and what group you're part of. Each of these people is working on some pretty cool research that can be related to VR and AR and is kind of right on the next edge. So definitely pay attention. Thanks.
So I'm Nikhil Naik, and I just graduated from the Media Lab from the Camera Culture Group. And so my research is primarily in computer vision on how to understand images and videos, and also how to understand how people perceive images, how you can understand, quantify human perception of visual data.
My name is Achuta. I also did my doctorate here at the Media Lab, and now I'm starting a position at Harvard as junior faculty. And the idea behind my work is also in computer vision. But I take a more of a physics-based approach. So we try to build the cameras and the displays that allow us to interact with photons. Can we build cameras that can track robots and allow self-driving cars to navigate the world? Or also doctors to see inside the human body?
Hey, actually, Achuta, just how many times has your research been on the homepage of MIT?
We've been fortunate to have our team's work covered multiple times.
So how many times has your work been?
I think maybe 4 or 5.
4 or 5. How about you?
Maybe a couple of times, yeah.
So, yeah, sir.
Hi, I'm Fernando, and I'm a master's student here at the Media Lab, my first year. My research is focusing on education, specifically using AR and VR. And I think the potential for education using these technologies is huge, and I'm very excited to see what we can do with it.
Hi, my name is Xin, and I just graduated from Media Lab Fluid Interfaces Group. I'm now the arts curator of the Space Exploration Initiative in the lab. My work in the lab is a lot about multi-sensory experience.
Space referring to like the space in your living room?
Up there.
Or, yeah, outer space. Maybe say a little bit more about that.
Yeah, so we're having a space exploration initiative in the Media Lab. So the goal is to, first of all, imagining and prototyping the sci-fi future, very interdisciplinary. So there's scientists, engineers, artists, and designers. At the same time, we're trying to democratizing the idea of space access. It's a bit off topic, but my own research is a lot about like multi-sensory experience, and I'm interested in how we can alter the perception of oneself and the perception of the world by giving them different kind of feedback and stimulations.
Let me try. Hi, I'm Ryan Zhang. I'm from the City Science group here at MIT Media Lab. So I'm a PhD student and research assistant. So what we are interested in how to improve the future cities, especially in the high density urban environment. So we focus on a lot of things like urban decision making support. Surprisingly, we are using AR and also very ancient technology here, Lego. So I will talk more about this, why we use Lego in my 9-minute talk. And also we work on self-driving bikes or tricycles, which we believe is the future. And we have robotic furnitures, which solve the question of the price of high-density city is so high so that they price out the young people. So anyway, we want the future of the city to be decided by people, by anyone. Yep.
Just on that, I went to Shanghai in 2008, and I remember going to this big building that showed Shanghai in 2020. And it wasn't, and the head of urban planning for Shanghai was a friend of mine, and she said, we didn't really ask people for their input. We just said, this is what we're gonna do, and we showed people. And the work you're doing, you're creating models of cities with Lego, and then you can manipulate data projected on the cities for people to see what different choices would make. So you could democratize the input. So instead of saying this is what we're going to do, you can have people have a voice through AR and Lego. So I'm just sorry to jump the gun.
Exactly. I think you are a crazy good summarizer. And I want to add just one more point to the democratizing. Another part is how to quantify all these metrics in the city, and how can we use simulation, use data analysis to make all this information available to anyone. Yep.
Cool. First question. So Nikhil, you do a lot of work with deep learning. It's the future. Everyone knows that it's going to solve everything. Why isn't it solved AR problems yet?
That's a good question. And I think maybe for the 1% of you who haven't heard about deep learning maybe today, it's basically a machine learning technology based on neural networks, which has created great improvements in machine learning over the past few years, and especially in computer vision in the task of understanding images and visual data. So what we can do now very accurately is we can identify what objects are present in the picture, we can identify where they are, we can even assign a label to each pixel to figure out what object that pixel belongs to. And all of this is very useful potentially in augmented reality, because if you want to essentially augment the scene by introducing new objects, it's very helpful to be able to know what different things are present in the picture and where are they spatially located. And so deep learning can essentially do this with very high accuracy, sometimes reaching human accuracy. But as Hisham rightly mentioned, it's still being slowly introduced into the world of augmented reality. And I think the main challenges there have been problems of computational power. A lot of these deep learning methods are very computationally expensive, meaning that you need to use a lot of computing power to be able to understand this data using machine learning models. And when you are running a system that needs to work in real time at multiple frames per second, there are trade-offs in regards to how complex of a machine learning model can you run, how can you run it on chip, how can you then run it in sync with other systems running on your computer so that you can actually understand the scene and then effectively use this data to create real-time interactions and interventions in the scene. So to summarize, I think it's a great opportunity for to bring in these advanced deep learning techniques into augmented reality, and we need to solve, I think, primarily engineering challenges on making these methods more efficient and faster to be able to use them in real time and to be able to use them seamlessly in combination with other methods.
Thank you, thank you. Yes, absolutely. And you were saying earlier that there are ways of doing that. You think that there are ways of tailoring these algorithms. Is it a completely different learning process, you think?
So I think it can probably come from a combination of things. So one is that taking existing models and making them more efficient. So there are computing tricks, there are optimization tricks, which can be used to make these more, more efficient computationally. And then creating special purpose hardware, which is tailored to run these algorithms, is another way of making these methods faster and more practical. So I think the improvements will come from a combination of software and hardware, where you're creating new techniques to make this more efficient computationally, and you are combining that with special purpose hardware to make this more efficient.
Thanks very much. And my next question goes to Shin. Shin, what is it that we're missing? What is it that we're not seeing? You've seen a lot of the AR talks and a lot of the things happening right now. What do you think that we're missing here?
My own research doesn't do much about giving information in a very explicit way. I try to do things that in a way kind of hidden and like trick people almost. So I'm interested in augmented reality in a way that is actually coming from more sensorial experiences. So for example, like AR, of course I can change the color of the room by giving it a blue light or a red light, but I know it. But what if the devices and like always on devices, especially giving me the hints of the reality through a way that is like through smell or through like a kind of similar sound but altered. So you think you're hearing someone talking to you, but then their accent is changed. Would you have a different idea about what's going on? So I think in Fluid, like lots of people are exploring in a way that is more using Judith's word is subliminal interfaces and things that like interfacing with people, but augmenting the reality, but without letting them know what's going on.
Well, that's interesting.
I want to add 2 cents. I really like the approach here because you are mentioning exactly what's missing. We are focusing way too much on the visual, but how about audio? How about sound? How about psychological effects? These are all the different layers we should explore.
Very good point. And Fernando, did you have something you wanted to add to that, especially like when you connect that to education?
Well, I think in general, what's missing in education is actually putting these technologies out there. I think it's clear that this AR technology is superior in many ways to run things like simulations or models. We could basically replace all of those in favor of AR technologies. We actually developed an application in my group called Mathland, and it lets you play around with physics in an AR world. So for example, you can throw a ball and pause the ball in midair to see its projected trajectory, to see where its velocity is going. And this kind of stuff is very, very helpful for learning things like physics. You can actually see the forces acting on an object, and even more, you're not bound by the physical laws of our world. So for example, you can change the gravity and see how that will affect the ball, or you can add other forces and play around in a way that you wouldn't be able to play around even with the most expensive models here.
Yeah, one example is also from Fluid and also about education is like, even though it's in a VR content, is Scott's work. They're talking about how the future of classroom could be in virtual reality, and they play with actually the position of the students. So when you think you're more on the front line of the classroom compared you at the back, you actually have a very different performance because you feel like more engaging, or like you feel like the virtual teacher give you more eye contact. So that's always very interesting.
That is very interesting. And I could definitely have used that. Maybe we all could have used that earlier when trying to understand optics, right? So one of the really cool things about the Media Lab is
Just on that point, you know, if you look at high school curriculum, I think you learn physics in the US your junior year. But I think with this technology, you could be learning physics when you're in 3rd grade.
Exactly.
Because it's so intuitive. I mean, you know, photography, f-stop, you know, ISO, it's very hard to use the cameras that use film, but now anyone can use an iPhone and do photography. And I think you're democratizing learning of some complex skills with this, and I think that's where you're going. So I also want you to say something because you're really clever, and I feel like you're leaving Achuta out.
I was just about to say that, yeah, we're pretty interdisciplinary here at the Media Lab. So Achuta right now is focusing on things that are not just going to affect AR and VR, but also the future of self-driving cars and everything like that. Could you please introduce a little bit more about what you're doing?
Yeah, sure, my pleasure. So the way I see, for example, AR and VR is I see it as a systems level approach. So we need to think about first principles across the whole stack. Let's take a concrete task. Let's say you wanted to Skype with your grandmother in essentially teleportation, right? You want to virtually teleport your grandmother from a different country. So you need a really good display because you want to see her in very high fidelity as if she's in the room with you. You, of course, need very good computer vision capture because wherever she is in the world, you need to digitize her in order to re-render her in your device. And then, of course, you have bandwidth, you have frame rate, and so on. And so the great thing about VR and AR is that it's going to involve practitioners from a variety of fields in EE, electrical engineering, and computer science. So for my background, for example, working on autonomous systems like self-driving cars and helping them navigate, we're looking at how the 3D cameras, the LiDAR devices that we build for self-driving cars can enable you to digitize the world around you and be embedded into AR, VR headsets. And so to sort of summarize in short, the punchline is here that AR and VR is a sandbox, it's an ecosystem for people across any discipline.
Very interesting. And I think that brings it back into this concept. I love that the interdisciplinary nature of both the Media Lab and AR and VR definitely connect. Do you guys find that when you're working in your individual groups that these concepts come up a lot? Are your advisors more pliable to AR and VR, or do you feel that this is something that your advisors aren't say totally on board with? As a little bit of, you know, like a callback, I mean, AR and VR has technically been around since the 60s. So a lot of the professors at the Media Lab have seen it come and go and come and go again. So do you find it difficult to convince people?
Great question. I think it's a brilliant question. I want to say that actually, so in our group, we want people to understand the city, understand the impact of their decision very intuitively. So AR, VR, by default, is very, very good tools because it's with a scale. It's not anymore on a screen with an abstract scale. It's a consistent spatial sense so that they can instantly navigate. But one trade-off, and also one of the principle my advisor, Ken Larson, don't like about AR, more like typical thinking of AR is the headset. Because while you're using the headset, especially the ones nowadays, it's very bulky. It actually blocked the conversation between different people. So we want a very inclusive conversation. We use Lego because we want everyone to participate the decision making, but we don't want to block the communication. That's one of the trade-offs. So I think to answer this question, we need to be very specific. We don't accept as all or we reject as all. We need to pick our right device, right technology according to the.
For the rest of you, just do yes, no, and then when you two go, I have something to say about what you say, and then I want you to bring us home about what you're up to. Yes, no. When you were in a group here, AR.
I'm in the group for VR and AR.
Okay.
So,
All right, so
every
that's yes.
demo you see is from my group.
Yeah.
Same thing.
Yes. Okay. I'm interested in what you have to say about your group.
So I think my response to this echoes Achuta's thought on AR and VR as a sandbox, in that in our group, we usually develop technologies for creating better cameras or improving computer vision systems. And one concrete application of those technologies is augmented reality or virtual reality. So to give an example, several people in our group have worked on time-of-flight sensors, which are 3D cameras, which can be very useful in AR systems when you put them in a compact format in AR headsets. So we built technologies which essentially improved the 3D information that you collect from the time-of-flight sensor, and that in turn can improve your AR experience. So in some ways, we developed tools that can find their way into applications like AR and VR as much as they could find their way into an application like a self-driving car.
Yeah. So did you want to say anything, or you're good?
Yeah, no, I agree with Nikhil. So about side swipes, right? So AR, VR is one of those unique areas where people should not abandon their home community. If their home community is efficient coding, or if their home community is building better cameras, they can still contribute to AR and VR, and we should encourage that.
Yeah. So Ramesh, the PI for camera culture, you two are both off to Harvard, or you're at Harvard, but your PI, he wrote the first book on augmented reality. He has many, like 50 patents, many of them relate to it. I think he's skeptical on it, and he thinks that projectors and interacting with information without the headset is going to be the way to go. And so it'll be interesting to hear what he has to say later today. I wanted to try to create some controversy, but you didn't go there. All right. So bring us home. Bring us home.
So I would say in my group, there's a heavy amount of cynicism for VR and AR, and I think that's been actually extremely healthy. We focus on, right now, AR and VR for production, both news and events. We think that brings AR and VR into the space of useful and not necessarily cool, which I think is exactly where technology might need to be to transition from the snake to the glasses, like as I said in the last presentation. That being said, I think there's still a lot of space for imagination, and I think that even as a community, everybody here, I don't think we have really applied all of our imaginative forces towards it. And I think that as we have tools that are more available to more people, we'll get to see some really cool stuff come out. So I think we should. I'm actually very grateful for the.
Where you were 2 summers ago, or you want to keep that?
Oh, sure. I was an intern at Magic Leap, and that's as much as I can say about that.
Yeah. or maybe he couldn't say that, but now you know.
Right. Awesome. Yeah.
All right. So, ladies and gentlemen, this was the trailer. Who likes these guys? Yep.
We love you guys.